So today's video is going to be a quick reminder of how we simplify rational expressions. And rational expressions we also just call fractions. The reason we care because a lot of time when we're working with the quadratic formula, we get some fractions that we need to simplify. So this helps us with that. Our main idea for today is making sure that we can only simplify fractions if all of the terms have a common factor. We can't just cancel out terms through plus or minus signs. So as an example, if I see something like 3 plus 6 over 3, I can't just cancel out the 3's and get this as the number 6 because that's dividing only one of the terms. And if we have a fraction and we need to divide all of the terms, right, they all need to have a common factor. So we can't just cancel them out like that. We can easily prove to ourselves that 6 is not the right answer. If I just add the numerator numbers and divide by 3, the correct answer should be 3. So if I just cancel out the 3's, I get the answer of 6. That's clearly not right. So when we are simplifying fractions, this is what we always do. We factor the numerator, we factor the denominator, and then we reduce the common factor. So for example, if we look at the first one, and here we're just practicing our factoring before we go on to some more complex ones that have square roots. But if I look for the greatest common factor of the numerator, that is 3. So if I factor out a 3, I'd be left with 2 plus 1 on top, right? If I divided 6 by 3 and 3 by 3. And on the bottom, I have a 9, which I'm going to write as 3 times 3. So because 3 is being multiplied by something on top and 3 is being multiplied by something on the bottom, I can reduce the 3's. And this could be written as 2 plus 1 over 3. In which case I could simplify. That's 3 over 3, which is equal to 1. And I would get that same thing up here. But again, we're just practicing factoring and reducing the factor. So let's do, I'll leave number 2 to your practice. Let's do number 3. If I look at number 3, if I look at the top, the GCF on top is a 2. So I'd be left with 3 plus 1. And on the bottom, I could factor out a 2 from the number 6 and write it as 2 times 3. So I could cancel out the common factors of 2, and I could reduce that to be 3 plus 1 over 3. So it's nice to start with numbers just so we get the feeling. I want to move on and do number 6, or let's do number 5 and number 6. So when I look at number 5, there is no GCF on top, which means I can't simplify this. The only thing I would be able to do is add the numerators and divide by the denominator. When we approach number 6, just so we can start to see some more complex types of fractions here, the GCF on top between 7x and 14 is just a 7, so I'd be left with x minus 2. And on the bottom, I could rewrite 49, I could factor out a 7. So I could cancel the 7's. I would get x minus 2 over 7 is how this would reduce. Let's continue looking at something like number 7 and 8. So if I look at number 7, on top, the GCF is only an x. So I can pull out an x from both of those terms. So I get 3 plus 2x left on top. And on the bottom, I could factor out an x. If I factored out an x, I'd be left with 6 times x squared. So I can cancel or reduce that common factor. What I'd be left with would be 3 plus 2x on top divided by 6x squared. And that's as far as I can go because there is no common factor on top. So if I can't factor anything out of the numerator, I won't be able to simplify it with the denominator. So our last one on this this type of problem will be number 8. So on number 8, again, we're going to try to factor the numerator. The numerator has an x and a 7 in common for both of those terms. So I'll factor out a 7x. So I'd be left with 2 plus 1. And then on the bottom, I'd be able to factor out an x and write that as x times 15. So I could reduce the x's, right? One x on top, one x on the bottom. So I'd have 7 times 2 plus 1 over 15. And then after that, I could choose to maybe distribute the 7 back or something. But again, we're just practicing factoring the numerator and canceling common factors. Now, more specific to how we'll be using it in class, when we have been using the quadratic formula, we get answers that look something like this. So let's pretend we were doing the quadratic formula and we were trying to simplify this fraction. What if we got this was the answer for x, and we were trying to simplify that? So when we're working with square roots, the idea is the same, but the only difference is we want to simplify that square root first. So I'm just going to rewrite this a few times. So I'm going to keep the 6. Now instead of the square root of 132, I'm going to break that down into a perfect square that I know, like 4, times one that I don't know, like 33. And then it's still a 6 on the bottom. I'm going to evaluate the perfect square. So the square root of 4 is just 2. And then I have a 6 on the bottom. So I've simplified the square root. And once we've done that, the steps after that are exactly the same as we just did before. So I'm going to factor the numerator. So the numerator is made up of a 6 and 2 root 33. So I could factor out a 2. And that'd be left with 3 plus or minus the square root of 33. And again, I could check, make sure by distributing that back. And on the bottom, if I'm going to cancel a 2 on top, I'd need to rewrite the number 6 as 2 times 3. So I'd be able to cancel that. So my simplified form would be 3 plus or minus the square root of 33 over 3. And I can't go any further, again, because there's no common factor in that numerator. So that's how I know that I am done. So we'll do a few more examples here. Let's work on number 1 here. So let's simplify the following fractions that have radicals. So just like we did before, we should first rewrite the radical. So instead of root 45, we could call that root 9 and root 5. And then on the bottom, we still have a 6. And if I evaluate the square root of 9, that is just 3. So transferring my work down here now, which I'll copy and paste. If I had this, if I wanted to simplify it, I would need to factor the numerator. So I looked at 9 and 3 root 5. They have a common factor of 3. So I could rewrite this as 3 plus or minus the square root of 5. And on bottom, if I wanted to cancel a 3 on top, I could rewrite the bottom as 3 times 2. I can cancel the 3's. So I have 3 plus or minus the square root of 5 divided by 2. Moving on to the next example, we'll start the same way. We'll have to simplify that square root of 12, and we can write that as the square root of 4 and the square root of 3, all being divided by 20. And I can go ahead and evaluate the square root of 4 to be 2. And then on top, I'd be able to factor out a 2. I'm going to write below as 2 times 7 plus root 3. And on the bottom, I could rewrite 20 as 2 times 10. So my simplified form would be 7 plus or minus the square root of 3 over 10. For a look at the next example here, again, I have to start with the numerator and taking care of that square root. So negative 9 plus or minus, I'll rewrite that as root 9 and root 3 divided by 9. So if I evaluate the square root of 9, that turns into a 3. And then to simplify this, I'll factor the numerator. There's a 3 in common. And then on the bottom, if I want to cancel a 3 on top, I'd rewrite 9 as 3 times 3. So I could cancel that. So my simplified form would be negative 3 plus or minus the square root of 3 over 3. Our last example here, I'd have to break or simplify the square root of 45, which we saw before as root 9 and root 5 over 16. So then if I simplify the square root of 9 just to be the number 3, I get 16. Now here, if I tried to factor the top, I can't. So that would be my simplified form. And to end our video today, I just have another example of like, well, why do we care? Like, where does this all come together? Well, in practice that you're doing in class, you're probably going to have to solve an equation using the quadratic formula. And when you do that, you tend to get an answer. So this would be one full problem of start to finish with a quadratic that would force you to simplify. So if we try to solve this with our quadratic formula, we could label our a value, our b value, and our c value. So then we could set up our equation. X, the answers that would make our equation true would be the opposite of b, plus or minus the square root of b squared minus 4 times a times c. And that whole thing is being divided by 2 times a. So as we simplify, negative 8 plus or minus the square root of, and the number under the square root, the discriminant will simplify to be 40. And that should all be divided by 6. So we can see that this looks like the type of things we were just simplifying, but I can't leave my answer like that because I need to simplify for my final answer. And that should probably be in the directions of a lot of work that you're doing. So here, as we said before, I would need to first rewrite the square root. So I need to simplify that. So instead of root 40, I could do root 4 and root 10. And I know the square root of 4 is just the number 2. And then from here, I can now try to factor the numerator. So on top, I could factor out the number 2 and get negative 4 plus or minus the square root of 10. And on the bottom, I could rewrite the number 6 as 2 times 3. So I could cancel the 2's. So the most simplified form of my answer would be negative 4 plus or minus the square root of 10, all divided by 3.